All right, in this video we are going to talk about something called phase diagrams. The idea is that for any given set of pressure and temperature, we need to know whether things are going to be a solid, liquid, gas, supercritical fluid, whether it's going to be boiling, melting, freezing, any of those type of things. And there are a lot of materials that have weird conditions, and we just need to know, under what conditions can you have it be a solid? What conditions can you have it be a liquid? So I'm going to draw just kind of a stereotypical, not a specific compound, something called just a phase diagram. And what these are basically a graph of pressure versus temperature. So up the y-axis, pressure is increasing, and on the x-axis, temperature is increasing. Okay. And usually what we have is a division like this. It usually looks something like this approximately. Okay. So if we glance at this, if we have really low temperatures and really high pressures, so everything's really cold and crushed together, we would expect things to be a solid. Okay, so this chunk over here is solid. Okay, the opposite extreme, if we have really high temperatures and really low pressures, what's happening is there's enough energy for things to overcome the intermolecular forces, and there's no pressure to hold them together. This is where we'd expect things to be gases. The little in-between area is where liquids exist. It's always going to be like where this little middle point is and how steep these lines are varies a little bit, but it's always going to be this layout. Okay? Not a huge deal. If, let's say, this is 1 atmosphere, or 760 millimeters of mercury, whichever unit you like. Okay? I'm going to try to draw a nice straight line. I can't guarantee I'm doing a good job, but we'll figure it out. All right, so this is the normal melting point. So when you're going from a solid to a liquid, it's melting, right? And it's normal because it's at 1 atmosphere. Okay, I will tell you this line tends to be pretty much vertical. I can't guarantee I drew it very vertically, but really if you change the pressure, the melting point's pretty consistent. This little bit right here, we actually saw earlier. This is the vapor pressure curve. We actually saw this curve already. And where it crosses from a liquid to a gas at 1 atmosphere is the normal boiling point. Okay. If you run this reaction, or if you have all these phase changes occurring, I guess it's not a reaction. If you're heating and cooling things in a closed system, what'll happen is you'll get to this point up here where things get a little weird. This is the critical point. I guess I'll switch colors here. Which we saw a couple videos ago, something called the critical point. And the idea is if you keep heating it and keep increasing the pressure, you end up with supercritical fluids, where it doesn't really exist as a liquid or a gas anymore. It's somewhere in between. Okay, so we've kind of talked about that. This point right here, this point down here is the triple point. And it turns out that for any given constant, or any given compound, the triple point is a constant. Okay, so let's talk about triple point for a minute. I'm also going to try to find a YouTube video of a triple point so you can see what it is. It's kind of a cool little video. A triple point is the exact set of temperatures and pressures where you have a solid, liquid, and a gas all existing at the same time. Okay, it's not difficult to have a solid and a liquid together. Okay, so like think ice water. Okay, it's also not difficult to have liquid and gas together. Think boiling water. It's difficult to have ice and water and steam all happening at the same time. It is technically possible for any compound to have something called a triple point. So this is where the solid, liquid, and gas all exist at once. Okay. And it's a constant for any given compound. So we said you can use melting points for identification or boiling points for identification. You can also use triple points if you can find them for identification purposes. Okay, so every compound ever, every element has a specific triple point. Okay, phase diagrams are really common, especially in like upper level chemistry, where basically you're working with weird materials and you're like, okay, I need this one compound to be a liquid, I need this other one to be a gas. What temperature and pressure do I need things to exist at? So if it turns out like, oh, I need a low temperature and a high pressure, if this thing's a liquid and then you look at a different phase diagram and it's a gas at that phase, then you're in the right spot. Okay, so being able to know what phase things are going to be on based on temperature and pressure, because both of these are important, is kind of useful. Another thing to point out here is we can actually see all of the different phase changes occur. If you're crossing from solid to liquid, that's melting. Liquid to solid is freezing. Liquid to gas, whether you're going this way or this way, is boiling. And gas to liquid is condensation. And so if you go this way, this is heating it up to get water to boil, or a liquid to boil. If you go this way, this is dropping the pressure, which we talked about on the pressure curve. If you drop the pressure, you can actually make things boil at low temperatures. Sublimation is all down here. If you're going from a solid to a gas, in skipping the liquid phase, you have to cross this line down here. Deposition. So going from solid to gas is sublimation. Going from gas to solid is deposition. Okay. Yeah. So this is kind of one of those things that I don't need you to be like an expert at phase diagrams. We're not going to like spend a huge amount of time on this, but it does summarize all the different phase changes and all the stuff that we've seen pretty nicely in one fell swoop. It's got all the details here. If you don't have a closed container, a lot of times you won't see this part up here. If it's open, if you're just like heating this thing in an open beaker, you'll never get a supercritical fluid, and this line will just kind of continue forever. Okay, but it's a nice, easy way to kind of like work your way around the system. Okay, all right, thanks.